Hey everyone, it's me, Miss Black, and we are continuing on our lecture of trigonometry and defining the 6 trig function values. When I last met with you all in the last video, what we had done is we had taken the ordered pair of point, plotted it on the xy axis, drew our right triangle, and then did our 6 trig definitions. So if you recall, our definitions of our 6 trig functions, according to a right triangle, is sine theta is y over r, cosine theta is x over r, tangent theta is y over x. And then we have the 3 reciprocal functions. So cosecant is the reciprocal of sine, secant is the reciprocal of cosine, cotangent is the reciprocal of tangent. Now what we want to do today in this video is figure out what we do to define the 6 trig functions if we cannot draw a right triangle. And you're saying, why would we not be able to draw a right triangle? Well, to draw a right triangle, remember, when we draw our right triangle, we're starting our angle in standard position. So if we recall standard position, our vertex point goes on the origin. Our initial ray always goes on the positive x-axis. And then what we saw in the last video is our terminal ray will rotate either counterclockwise if our angle is positive, clockwise if our angle is negative. But in the last video, our terminal ray landed inside one of the quadrants. So if our terminal ray lands in quadrant 1, we could draw the right triangle. If our terminal ray lands in quadrant 2, we could draw the right triangle, and etc. What's going to happen today is our terminal ray is not going to land inside a quadrant. It is going to land on another axis. For example, our terminal ray may land here on the positive y-axis. Well, if that happens, we cannot draw a right triangle, because the definition was to draw the right triangle, you drop a perpendicular to the initial ray. So if I put my terminal ray here, there's no way to draw a perpendicular from the terminal ray to initial ray, because the terminal ray is perpendicular already. So what we're going to find out is when our terminal ray lands on one of the axes, that's a specific angle measurement. As we know, our quadrants go in multiples of 90. And multiples of 90 are called quadrantal angles. That's your new word. What is it? Quadrantal. Quadrantal means your angle is a multiple of 90, which means the terminal ray will land on one of the other axes. And if that happens, you cannot draw a right triangle. So then we have to change the definition of the 6 trig functions. So if your terminal ray lands on the axis like the positive y, there's no way to draw a right triangle here. So in order for us to define the trig functions when the terminal ray lands on the axis, we can't use a right triangle. We're going to have to use a different shape. And the shape we're going to use today is the unit circle. All right? Now, from good old algebra, college algebra, you learned the equation of a circle. The equation of a circle is x minus h squared plus y minus k squared equals r squared. And if you remember, to graph a circle, you need 2 components. You need to know where the center of the circle is, and you need to know where the radius is. The unit circle is always going to be located in the same position. For the unit circle, the center is going to be the origin. And in this equation of the circle, if you remember from college algebra, the center of the circle is represented with the variables h and k. So if the center of our unit circle is always going to be the origin, this equation now is written x minus 0 squared plus y minus 0 squared equals r squared. Well, in algebra, if we simplify x minus 0, that's just good old x. And x squared is x squared. Plus, if we simplify y minus 0 is y, and y squared is y squared. So the equation of the unit circle is x squared plus y squared equals r squared. If you remember, for circles, r always stands for the radius. The radius is the distance from the center of the circle to one edge or one vertex. For the unit circle, we're going to go a radius of 1. So this is going to be 1 squared. So the equation of the unit circle is x squared plus y squared equals 1. Now, why is that important? Because we're going to use the coordinates, the 4 vertices of the unit circle, to define our 6 trig functions. So if I said draw me the unit circle, here would be the origin, 0, 0, and the radius would be 1. So if we move to the right 1, the coordinate here is 1, 0. If we move up 1, the coordinate is 0, 1. If we move to the left 1, the coordinate is negative 1, 0. And if we move down 1, the coordinate is 0, negative 1. And that would draw us a unit circle. So what happens is, in trigonometry, if I give you an ordered pair and I want you to define for me the 6 trig function values, but when you plot that ordered pair, that point, you can't draw a right triangle because the terminal ray lands on one of the other axes. To define that trig function, you'll use the unit circle. Now, if you look, the definitions are not going to change meanings. From the last video, sine is y over r. It just so happens if we're using the unit circle, we know the r, the radius, is what number? It's 1. So y over 1 is just y. So on the unit circle, the sine value is your y value. The definition of cosine from right triangles was x over r. Well, if we're using the unit circle, the radius again is 1. So x over 1 is just x. So when using the unit circle, the definition of cosine is just the variable x. The definition of tangent doesn't change. It's y over x. If I'm given an ordered pair and it lands here, I'll have a x, I'll have a y. I'll be able to give the tangent value. If we do the reciprocal functions, cosecant from the right triangle was r over y. Well, with the unit circle, the radius is 1. So the cosecant value is 1 over y, which makes sense. Cosecant is the reciprocal of sine. If the sine value on the unit circle is y, the cosecant value is the reciprocal of it, 1 over y. Secant, the definition from right triangles, was r over x. Well, if we're using the unit circle, the radius is 1, so this becomes 1 over x. Secant is the reciprocal of cosine. If cosine's value is going to be x on the unit circle, secant's going to be the reciprocal, 1 over x. And then cotangent is the reciprocal of tangent. So if tangent is y over x, cotangent is x over y. So guys, it's not like learning 6 new definitions. It's the same definitions. The only difference is when your terminal ray lands on another axis, you can't draw a right triangle. So you'll have to define the functions using the unit circle. And the radius of the unit circle is always going to be what value? 1. Very good. So all you're doing is replacing in these definitions the radius value, the r value, with 1. Okay? Let's try one. So our first example in our notes, 1.3b, A, says define the 6 trig function values given this ordered pair, 0, 2. So we go back to where we started last week on the last video. We're going to draw an angle in standard position. So where do we put our vertex point? That's right, the origin. Where do we put our initial ray? That's right, the positive x-axis. Now we're going to put our terminal ray where this ordered pair is. So if we go plot 0, 2, the x value is 0, which means I don't move left or right. The y value is up 2. Well, if I draw my terminal ray, it goes right on the positive y-axis. So if you look, there's no way on earth we can draw a right triangle. From last week, the definition is to draw a right triangle, you drop a perpendicular from the terminal ray to the initial ray. If this is the terminal ray, there's no way out to draw a perpendicular to the initial ray. It's already drawn. These rays are perpendicular to each other. So there's no way to draw a right triangle. Don't be doing this, people. That's not the definition. If you connect from this terminal ray to this initial ray, like here, that is not a perpendicular. You're not following the definition. So when the terminal ray lands on another axis, we cannot draw a right triangle. Everybody got it? Good. The only way to do the definition of the 6 trig function values is to use our buddy, the unit circle. Now, this is how you use the unit circle. you're going to use these coordinates. But you're not going to use all 4 coordinates. You're going to use the coordinate that relates to the correspondence of where your terminal ray is. So guys, look, our terminal ray is here on the positive y-axis. So which coordinate for the unit circle is on the positive y-axis? It's this coordinate, 0, 1. We're going to use that coordinate, 0, 1, to give me the 6 trig definitions. If I was you, I would put above the 0 the x and above the 1 the y. So you don't get confused who's x and y. Now look how easy this is. The definition of sine was y over r. We don't got to worry about a radius here. So the definition of sine is just y. What's your y value? 1. The definition of cosine was x over r. We don't have to worry about a radius here. We don't have a right triangle. So we're just going to say the definition of cosine is x on the unit circle. That's 0. The definition of tangent is still y over x. So our y value is 1. Our x value is 0. And now here comes the fun. This is no longer a trig concept. This is an arithmetic concept. If I have $1 and I'm going to divide it by 0 people, how much would everybody get? That's a trick question, people. You should all know by now there's no such thing as dividing by 0. How can I take something and break it into no groups? So in algebra and arithmetic, we have learned if you cannot divide by 0, this doesn't have an answer. If it doesn't have an answer, you can't represent it with a number. So we give it a special word that says it has no value. And the word here is undefined. Okay, so remember that. We talked about that good old 3rd grade math. You cannot divide by 0. All right. Now, the reciprocal functions, you have no work. You do the reciprocal. Cosecant is always the reciprocal of sine. So if sine is 1, if you flip 1, it still becomes 1 over 1, which is 1. Secant is the reciprocal of cosine. So if you take 0 and flip it, let's think about this now. 0, you take 0 and you write it as fraction, it's 0 over 1. You can make any whole number a fraction by dividing it by 1. Now, sweethearts, this makes sense. If I have nothing and I divide it among one person, they're going to get nothing. 0 divided by 1 is 0. Secant is the reciprocal of 0. So if you flip this, it would become 1 over 0, which again is undefined. So the reciprocal of 0 is always undefined. Cotangent is the reciprocal of tangent. If tangent was undefined because it's 1 over 0, then if we flip that, it becomes 0 over 1, which is 0. So that is how you define the 6 trig function values if you cannot draw a right triangle. Which, you know what that means now, guys? It means now you have to memorize the unit circle. You have to have this memorized. Okay? There's no way out of it. You have to know the coordinates of the unit circle. 1, 0, 0, 1, negative 1, 0, 0, negative 1. Anytime you're asked to find the 6 trig function values and you're not able to draw a right triangle, you have to use the unit circle. So this has to be memorized information. You also have to realize anytime you draw where the initial ray and the terminal ray are on the axes, you're drawing what we call quadrantal angles. What kind of angles? Quadrantal. They're multiples of 90. So if you see I labeled 0 degrees, 90, 180, 270, 360, 450, 540, 630, and we keep going on and on and on. Any angle that lands on the axes is a multiple of 90. It's a quadrantal angle. And if you're asked to evaluate quadrantal angles, you have to use the unit circle. So let's go to example 2. Now, example 2 has a lot of parts to it in your notes. We're not going to do all of them. I'm going to skip around, but I want to show you why memorizing this unit circle is going to be important. So if we go to 2, let's do 2a. Start there. The directions say evaluate each expression without your calculator. We'll learn in the next chapter how to use our calculators. Right now we have to understand the meaning of what trig is. And if you just go and use your calculator, you'll never understand what trigonometry is. So without a calculator, I want to know the exact value of cosine of 90. Remember, evaluate means give me a value. A value is a number. When you put a value on something, you put a number on it. Like when you put the value on your house or on a piece of property or jewelry or, anything you own, your television, you put a number on it. I want to know what the cosine of 90 is. Well, if you think about that, if you drew a 90-degree angle, okay, you'd put your vertex at the origin. You put your initial ray on the positive x-axis. To draw an angle that's 90 degrees, your terminal ray would go on the positive y-axis. You clearly cannot draw a right triangle. So to evaluate the cosine of 90, which we know the definition is x over r, we can't use the right triangle. We would have to use our unit circle. So we would go over here and say, okay, I know my unit circle. When my terminal ray lands on the positive y-axis, I'm going to use this coordinate, 0, 1. And now we'll just fill in our definition. The x value here is 0. The radius of the unit circle is always 1. 0 over 1 is 0. And that's the cosine of 90 degrees. Make sense? It's really easy. You just got to be able to use your tool that you have to memorize. Let's do C. C says the sine of negative 270 degrees. All right? So again, I'm going to go slow, piece by piece. The first thing I'm going to do is draw my visual. So there's my xy axis. I'll put my vertex point. I'll put my initial ray. If I'm drawing an angle that's negative 270 degrees in standard position, remember that means we're going to rotate clockwise. So this would be 0 degrees. This would be negative 90 if we're going clockwise. Negative 180, negative 270. So our terminal ray would land here also. Make sense? Only now we're rotating this way. Okay, on the first one, A, we were rotating counterclockwise. See the difference? All right, so again, if this is my initial ray and my terminal ray lands on another axis, I cannot draw a right triangle. So what I need to do is use my unit circle. How do I decide which coordinate to use? It's where the terminal ray lands. My terminal ray is landing on the positive y-axis, so I go up here to the positive y-axis. I'm going to use the coordinate 0, 1. How do I use that coordinate? I do my definition. The definition of sine is y over r. Well, the y value here is 1. The radius of the unit circle is always 1. There's my sine value. So the sine in negative 270 is the value 1. Everybody's good? Okay. Let's try the next one. Let's go to E. This is cosecant a negative 450 degrees. All right? So I'm a visual person. I need to draw. All right? Vertex point, initial ray. We're doing a negative angle, so which way are we rotating? Clockwise. So this is 0, negative 90, negative 180, negative 270, negative 360. If you go another negative, this would be negative 450. So quadrantal angles are multiples of 90. Quadrantal angles are where the terminal ray is going to land on an axis. So if I'm going to draw an angle that's negative 450, here's where the terminal ray is going to land. Remember, when I draw an angle in standard position, watch the rotation. I went around one full time. That was at negative 360 and a little bit more. So that should be what my arc looks like, just so you remember. All right? If this is where the terminal ray lands, I can't draw a right triangle. I have to use the unit circle. So I go over here and I match the coordinate with where this terminal ray is. So the coordinate here is 0, negative 1. So now, the definition of cosecant is the reciprocal of sine. If sine is y over r, this is r over y. In the unit circle, what's the radius? 1. If I look at my ordered pair, what's my y value? Negative 1. What's 1 over negative 1? Negative 1. See how easy that is? All right, we got a couple of more to try. let's go to G. Okay? Now, once you get good at this, you don't need to draw a specific picture for each expression you're evaluating. All you need to have out here is the unit circle and just count your angle. Okay, but I'm going to draw a picture visually for each one just so you get it. All right, let's look at G. G is 3 secant 180 degrees minus 5 tangent 360 degrees. I want you to evaluate that. I want that to become a number. Okay? So it's just like doing good old algebra. It's substituting and calculating. The first thing I got to do is figure out what the trig functions equal. Okay? The whole thing that you're learning here is if I give you one of the 6 trig functions and I put an angle behind it, I should get out a fraction or a number that it equals, that it corresponds with. So to look up the secant of 180, I'm just going to draw a visual here so you can see. And vertex point, initial ray. If I rotate to 180 degrees, I know my terminal ray is going to land there. There is no way to draw a right triangle. That is a straight angle. So what I want to do is I want to find the corresponding ordered pair from the unit circle. So I'm on the negative x-axis. So the negative x-axis, I would use this point, negative 1, 0. All right? Now you're going to say, what do I do with that 3? You do with that 3 exactly what you do with 3a. You leave the 3 there. We're going to look up the definition of secant. Secant is the reciprocal of cosine. Cosine I know is x over r, so I know secant's got to be r over x. So now if I look, I know my radius for the unit circle is always 1. And what's my x value here, people? Negative 1. So that gives me 3 times negative 1, which is negative 3. Isn't that cool? Now, we have another part. We've got to do the tangent of 360. Okay? Well, if I draw an angle that's 360, will the terminal ray land here on the negative side? No. If I draw an angle that's 360, see, this is 180. But now I want to draw a 360, so I'm going to draw that down here so you can see it. Okay? So let's put my vertex. Let's put my initial ray. If I draw an angle that's 360, I'm going to rotate all the way counterclockwise till I'm back here. So when I draw an angle that's 360, I really just drew a circle, right? Because the terminal ray and the initial ray land together. Want to look up the tangent of 360, because I can't draw a right triangle because the 2 rays are on top of each other, I have to use my buddy the unit circle. I would use this coordinate now, 1, 0. Okay? So this is minus 5. Tangent, we know the definition is y over x. Let's go to an ordered pair. The y value is 0. The x value is 1. 0 divided by 1 is 0. And negative 5 times 0 is 0. So now you have negative 3 minus 0, which when we evaluate this, we get a negative 3. That wasn't so bad. But again, it has to do with memorizing. If you don't have this unit circle memorized, you won't know how to evaluate your trig function. All right, we have 2 more in these notes. Let's keep going. Let's go to I, and let's see the major difference with I. I says evaluate the cotangent of 3 pi over 2. Now, let's integrate everything we've learned. We've learned in trigonometry, angles don't have to be just measured in the units degrees. What units is this, people? Good, it's radian measure. Well, you're not comfortable with radian measure yet. Me, I've been teaching for 25 years. I know what 3 pi over 2 is as degrees in the top of my head. I have that fact memorized. You don't have that memorized yet. So rule of thumb, right now, every time we're working with trig functions, you want your angle in degrees because you understand degrees. So guys, go back to what we've learned previously. How do you change radians into degrees? What's your conversion rule? If we want to change this to degrees, we want to get rid of the pi symbol. So what are we going to multiply by? That's right, we want to multiply by 180 over pi. If pi is in the numerator and we're trying to get rid of it, we need a pi in the denominator. So the pi's are going to cancel out. Now, if you recall, you could do 3 times 180 and then divide it by 2. But if you all remember from algebra, multiplication and division are equal. So what's quicker is to do the dividing first. So I'm going to divide 2 into 180. That's going to give me 90. And 3 times 90 is 270. So this really is looking up the cotangent of 270 degrees. Don't forget your degree symbol, because it's up there. Now, to look up the cotangent of 270 degrees, well, again, it goes back to the basics. To look up a trig function, you need to draw me a right triangle. So I put my vertex and my initial ray. If I'm talking about 270 degrees, 0, 90, 180, 270, my terminal ray would rotate there counterclockwise. There's no way to draw a right triangle. The definition says to draw a right triangle, you have to draw a perpendicular from the terminal ray to the initial ray. Well, guys, here's the terminal ray. It's already perpendicular to the initial ray. There's no way to draw a right triangle. So you have to use the unit circle. So the coordinate of the unit circle that corresponds with the terminal ray is 0, -1. That's the point we're going to use. What's our definition of cotangent? It is the reciprocal of tangent, so it's x over y. Our x value here is 0. Our y value here is -1. 0 divided by any number is 0. And we're done. All right, let's try one more. The last one is k. Let's try that one. And we want to look up the tangent of 5 pi. So again, you feel very comfortable with angles in degrees. I understand that. I agree with you. I'd much rather see degrees over radians. So we're going to go back and use our conversion. To change radians into degrees, we do the conversion times 180 over pi. That becomes your friend. You've got to have that memorized. The pi's are going to do what? That's right. If we write this as a fraction, 5 pi over 1, the pi's will cancel out. So we're left with 5 times 180 degrees. That's what calculators are great for. That becomes 900 degrees. So I want you to look up the tangent of 900 degrees. So the first thing I got to do is draw it and see where does the terminal ray land. Okay? So I'll put my vertex. I'll put my initial ray. All right, let's count. This is 0, 90, 180, 270, 360. Multiples of 90. This becomes 450, 540, 630. This becomes 810. Add another 90. This becomes 900. So do you all agree the terminal ray would land on the positive y-axis? When I draw that picture, I went around once. That's 360. I went around twice. That's 720. Oh, I screwed up. Guys, I made a boo-boo. I miscounted. Let me fix that. I did it bad. Let's do that again. Miss Black miscounted her 90s. Sorry about that. Let's try it again. 0, 90, 180, 270, 360. All right, we're doing multiples of 9. This is 9 times 4. So 9 times 5, that would be 450. 9 times 6 would be 540. 9 times 7 would be 630. 9 times 8 would be 720. 9 times 9 would be 810. 9 times 10 would be 900. I apologize. The 900 should land there. So now if we draw it, here's our vertex point. Here's our initial ray. And our terminal ray would land on the negative x-axis. So watch my rotation. I'm going counterclockwise because it's a positive. So I went around once, that made 360. I went around twice, that made 720. I went up here to 810, and I went here to 900. So that would be what that angle looks like if you drew it in standard position. The terminal ray lands on an axis, so you cannot draw a right triangle, so you have to use the corresponding ordered pair from the unit circle. So if I go to the unit circle, that would be the corresponding ordered pair, -1, 0. So to look up the tangent in 900 degrees, the definition of tangent doesn't change. It's y over x. The y value is 0. The x value is -1. 0 divided by anything is 0. See how easy that is? So what we learned in this section of 1.3b is to understand the definitions of the trig functions does not change. You have to have these memorized. However, sometimes you just can't draw a right triangle. And if you can't draw a right triangle, you define the 6 trig function values, you have to use the coordinates of the unit circle. Therefore, this has to be memorized also. All right, I'll see you in the next video.